All right, today I have really absolute honor speaking with Professor Suvrat Raju. He's a theoretical physicist working on string theory and black hole physics, and he's a professor at ICTS. But honestly, the reason I really wanted to talk to him is that he's very outspoken about human rights issue and public policies. So thank you, sir, for joining us today.
Thank you.
So let's talk about the how the Indian state award the scientist. So historically, India's highest award was Santi Swarup Bhatnagar Prize. But recently, the government changed name into Rashtriya Vigyan Puraskar and striped the monetary endowment. Now there is a report that last year your name was actually recommended by the selection committee, but at the last moment, because of your political activities, it was removed. So can you tell your story? What actually happened behind the closed doors?
Okay, sure. So, as you said, that there was for many years a very old award which was called the Bhatnagar Award, which used to be given to scientists under the age of 45. So it was given to mid-career scientists. Yeah. Now, one of the uh, the practice of this award was that the selection committee that made the decision was always kept confidential. Okay. So in many awards, it's a practice to actually reveal the selection committee, but that was not done for the Shanti Swarup Bhatnagar Award. As a result, there was a fair amount of criticism of the award saying, so and so got the award because their advisor was on the selection committee or so on. Uh, Also, in few years ago, there were no women in the list of awardees, so there was some criticism about that also. Why is it there was no women in the list of awardees? Now the thing was that when this criticism was made, there was no one to hold accountable, right? Because you don't know who the selection committee was. So the government of India said that well, we are going to improve the process, and they said, well, we'll make it transparent and we'll make it better than it was, which is what this government often suggests it'll do. So what they said was, we will introduce a different, or we will, absorb the Bhatnagar Award into an award called the Rashtriya Vigyan Puraskar. And the committee for the Rashtriya Vigyan Puraskar was declared. It was made, it was announced. This was the most significant thing. There were other small things like they stopped the monetary award and so on, but that's actually pretty insignificant, I would say. But the main change they made was they said that we will announce the committee for the Rashtriya Vigyan Puraskar. And this committee was called the Rashtriya Vigyan Puraskar Committee. And this committee comprised ex officio members. So it's chaired by the principal scientific advisor. It has the secretary of the Department of Science and Technology, the secretary of the Department of Atomic Energy, the president of the Indian National Science Academy, the president of the Indian Academy of Sciences, and so on. Yeah? So these are all what are called ex officio members, and that it's the person is there by virtue of holding that position. And a few scientists who are invited. Now, this committee doesn't have subject experts, but the idea was that they would convene subject committees, but finally they are the ones who are accountable for the award. So if something goes wrong, you can hold them and say, look, what went wrong, right? Why was the award given or not given or something? So that was the main thing, the main change that was made with the Rashtriya Vigyan Puraskar. Now, what happened in the first year of this award was that the day the awards were announced, the one of the members of the Rashtriya Vigyan Puraskar committee, this final committee, uh, congratulated me, accidentally, thinking that I should have received the news of the award. So this person, actually, I don't know the person I don't know the person very well. It was a completely good faith mistake. And the mistake was that, they had finalized the awards, they had made a citation, they had done everything. So they naturally assumed that when the awards would be announced, the list that they had signed off on would be the list that was announced. So this person, in good faith, completely good faith, without any intention of creating any controversy, uh, congratulated me. And of course, I had no idea what they were congratulating me about. And that is when the story came out that in fact, even though the government had made this show of transparency, of saying that they will have this committee that will make the final decision, this committee was not the final decision makers, and in fact, the committee's recommendations had been altered by the Minister of Science and Technology. What is more, the minister didn't even have enough respect to tell the committee that they were going to modify the decision. So the minister, treated the committee with such a lack of respect that they didn't, if they had told the committee members that, look, actually the minister is going to make the decision, the committee members would never have made a mistake like this. But they didn't even bother to have the decency to tell the committee that, look, your decisions are going to be changed and it's actually the minister who's going to make the decision. So that is why it, was a big shock even to members of the committee. Maybe not to all members of the committee, right? At least to some members of the committee. Possibly the chair of the committee knew this was happening. I don't know. But clearly some members of the committee, that's obvious, didn't know that the minister was going to change these decisions. After that, then it became quite clear what had happened, and it turned out that other names had also been dropped. And multiple scientists, some members of this selection final committee, some members of the subject committee, they spoke to the media, and there were then many letters that were sent by scientists and so on. But the whole thing came out because of this accident, and because the government made a show of transparency, but in fact it hid the fact that it was actually uh, going to change the award selection process so that the Minister of Science and Technology would be making the selections. So I can tell you a little bit more about what happened. If you should I say a little bit more about what happened after
Yeah,
that?
please do.
Okay.
What worries you more, like the direct political interference or scientists gradually adapting themselves to what they think institutions want?
Very good. So that's exactly the right question, right? So clearly, we don't have high expectations from the minister, right? The minister will do what the minister does, and it's very unfortunate that the minister lacks the respect for the scientific community to respect the autonomy of the scientific selection committee. But frankly, I don't have high expectations from the minister. This is what the minister does. Now, let me say a little bit about what happened after that, right? Which is interesting. So when the story came out, a group of scientists wrote former, winners of this Bhatnagar Award that we just discussed. They wrote to the principal scientific advisor, saying that we are concerned about this, and can you tell us what happened? Now, what the principal scientific advisor, frankly, I feel uh, if I had been in their position, I would have resigned. But instead of that, what the principal scientific advisor did was, first the government took the web page of the awards, they took it offline, and then they re-uploaded the web page, but they changed the rules for the award. So the earlier set of rules said, the the you know the set of awardees will be decided by the Rashtriya Vigyan Puraskar committee. Now the new set of rules said, well, the Rashtriya Vigyan Puraskar committee will recommend names to the Minister of Science and Technology. Yeah. So it is very unfortunate that the scientists who were part of the Rashtriya Vigyan Puraskar committee, right? The whole point of announcing the committee was that they would be accountable for these decisions. So that they kind of uh, didn't take a stronger stand. There were many scientists from outside who took a stand. So there was a letter by these 26 scientists. There was a bigger letter by almost 200 scientists, again writing to the PSA. But the scientists in the establishment just kind of, gathered around and tried to protect the government from the consequences of its actions. In fact, it's very, very interesting. But if you look at the initial report on this, the report was by the Telegraph newspaper. Okay? And you will see in that report that, so, they're reporting that this thing has happened. And then they speak to a scientist who the report describes as being familiar with the selection process. It's not hard to guess who that scientist is. And that scientist, at that point didn't have information about what had happened. This information I told you, right? That some member of the Rashtriya Vigyan Puraskar committee had congratulated me. So they tried to cover up. So they tried to say, well, actually, there were many committees. There was a subject committee and a final committee, and not all scientists were members of all committees. So they tried to suggest that, I mean, they thought that somehow I was getting, or this leak had come from the subject committee, and that the Rashtriya Vigyan Puraskar committee is the one who had taken the decision to drop my name. So this, this, and then immediately after that, if you just read that newspaper report, it's a report worth reading by Mudur, who's a very good journalist who wrote about this in the Telegraph. Immediately after that line, you say, well, but an email reviewed by the newspaper because shows that some members of the final selection committee were unaware of this. So it quotes the scientist and then immediately points out that what the scientist is saying is false. It's not a committee that made the decision; it's somebody else who made the decision. And if I had been caught like that, like making a statement to a national newspaper, which is just in the same report shown to be, a statement that's substantively misleading, I would have felt extremely perturbed. But somehow, I guess the people who run Indian science are okay with this. They seem to be okay with adapting to this kind of a situation and trying to cover up for the government. And I guess that's also true about what's happening later because it's quite clear even this year the minister made some statement about how there'll be greater scrutiny of the awardees and so on. So now it seems that, this is kind of the state of affairs that there'll be some committee which will make some recommendation and then the minister can delete or insert names. And, maybe some, right now it's quite clear that these deletions and insertions, I would say, are happening on the margins. I don't think the minister is wholesale changing the list. They seem to be, maybe they're inserting a few names and deleting a few names on the margins, people whom they don't like or they're deleting, and people whom they like a lot they're putting in. But the scientists who believe that they can adapt to the situation are really living in a fool's paradise because, we saw this happening in the central universities in this country, where initially the same thing happened that, there was a mild interference in the appointments. But soon after that, now we have reached a stage where it's, impossible to get a job in a central university, at least what is reported, unless one has the right political connections. So, the scientists who feel that we'll just adapt to the situation, I think are making a mistake. And, it would have been much better, of course, if scientists were to refuse to engage with a process that's as compromised as it is. And that is something important. So but you're right that many scientists are trying to adapt to the situation, and I don't agree with that. At least I don't think that's the right way forward because in the long run, I don't think that works.
So in India, so institutional autonomy only exists until it conflicts with the current government.
Th- that's true. I wouldn't say that the situation. Okay, I have not been part of the scientific establishment forever. My career in the scientific establishment as a faculty member is maybe about now 13 or 14 years, but maybe 13 and a half years. But I there's always been this tension, right? There's always been this tension. And frankly, just to say clearly, this tension was also present during the UPA times. It's not like before the BJP government came to power, this tension was not there. It was there even then that the government, if they felt that someone was writing articles which they didn't like. I mean, in my case, there was a lot of this tension. Then the government would put pressure to have those things stop, to have so it's not like this is a completely new thing, but I think we should appreciate that the levels to which the current government is interfering in the running of institutions are unprecedented. And the kinds of steps that the government of India is now willing to take to assert its political hegemony, or to make sure that dissidents or critics or those who don't agree with the line of the government are sidelined, those are rather extraordinary. And so just as yeah, so it's true that this tension has always existed in India, but it's become, I think, the situation now is very serious in terms of the autonomy and ability of academic institutions to take independent positions. And it's not just taking independent positions on social issues. The issue that we just discussed a few minutes ago is, after all, a purely scientific issue, right? All these scientists, they keep saying, well, we should make scientific decisions on scientific grounds. But the issue of the awards we discussed in the end is a complete violation of that. And it's, as I explained to you, it was purely by accident that that came out. So we don't know if the same thing is happening in other situations, in grants, in appointments, in many other settings. So I feel the situation is very concerning.
So, what does a PhD student who currently watching it? What should he learn from it? What should she learn from this? Should they should be afraid or like?
I feel that in a sense, it's our hope is only, is with the younger generation. And, I always appreciate and admire students, including many students at ICTS, who have not been afraid, who have continued to speak up, who have continued to take a stand. And in some sense, I feel that it's more important that students in universities and other institutions, should stand up and defend the basic democratic principles that are responsible in these institutions, right? There is What we are saying is very simple. We are not saying anything very complicated. We are just saying that members of universities and other institutions have their basic constitutional rights protected. And, they have those constitutional rights just by virtue of being in a university. Because the government can control the funding of the university doesn't mean that those people have to give up their constitutional rights. That's all that's being said. And, moreover, universities have historically been places where free debate is allowed. It's important, right? Because that's how ideas of the new generation get formed. So if when you're a student, you have these discussions. Sometimes as a student, you might even take extreme positions. When I was a student, I would sometimes have extreme views on things. I mean, that's how we mature politically. And the whole point is that we have to allow for those free and open discussions. And that's very important for the country. And so I think that the students who are currently in their PhDs or in their undergraduates and so on, they should continue doing the right thing, and they should not take their cue from the establishment scientists who, as I discussed, have taken a rather unfortunate stand in a lot of these issues.
Okay, so if the state is centralizing everything, the classical scape is that billionaire funding. Like if you look at the ICTS also being funded by Infosys. So recently in India, some groups have come and started to fund institutions. Like Lodha Groups has come along. They are started to fund institute in Mumbai. So they are saying that they will fund postdocs and host conferences. So they will just bypass the UGC rule. So is this basically they just want prestige, or is the private funding model actually viable for the scientific research?
Uh, okay, so let me divide my answer into two parts, right? One of them is the systemic part of what kind of funding model is good. And then second, it's a slightly different issue of, how scientists should operate in the current setup. So let me first say the first thing. I think from a systemic point of view, it's completely clear to me that, a public funding model is much better than a model where there is, private funding by very wealthy individuals. So I think it's clearly a problem to start with if one individual accrues so much wealth that they can decide the direction of research. Right? That's just a problem in our society. If we allow individuals, single people, to accrue so much wealth that they can then distribute and decide directions in society, including the directions of research. This kind of research is always problematic because it means necessarily that research directions will be, idiosyncratic, and they will, be distorted. Because, the billionaire or the wealthy person who is funding science is not accountable to anyone, right? They want to maybe they're interested in field X, and maybe that's good for scientists in field X, but they might not be interested in field Y. And so there's a field Y might be important for society. It might be very important for society. So there's a problem in how priorities are decided. Second, I think we should realize that these wealthy individuals are also susceptible to the same pressures. One only has to look at what's happening in universities like Ashoka University, where the same pressures have even far more significant pressures have been exerted on academics. In fact, in central institutions, major central institutions, it's very hard to you know to remove faculty members, but that has happened multiple times in private universities, in many private universities. So the idea that private universities can somehow serve as havens of democratic rights is not true. So I don't think that the private funding model has many other problems. Just to say something, as you say, what private funders are often looking for might be prestige or might be something else that somehow benefits their bottom line in a subtle way. And so those are all, and I don't think so. I don't think the whole model is a very good model. So a model where there is public funding for science, but the public funding for science, has a transparent process of decision making. It's not that, a minister can say that, oh, I don't like what some faculty member in your institution is saying, so I'll cut funding for the institution. That is a problematic setup. But a model where there is generous public funding for science and that funding process is done in a transparent way on a scientific basis is the correct way to go forward, in my opinion, on a systemic level. Now, that being said, the question is, in today's setup, what should a scientist who is operating in this setup do? Right? And the answer to that is much more tricky. So, if one is operating in this setup and one finds that funding is being cut by by the central government for whatever reason, and then, someone offers to step in and say that, we will cover up that funding, or we will offer you grants for some activity. Then I don't think it's, in the end, this is a decision that one has to make, uh, on the merits of that particular case. So, while I feel that on a systemic level, one would much prefer a model where there is, clear, transparent public funding for science. Many scientists who are operating under difficult conditions, it's very hard to say to them that they should not accept funding from whatever sources are available. So if those sources are if there are no specific strings tied to the research, if they're able to protect academic autonomy, then this is how they have to function in an imperfect system. Of course, it's important, as I said, one should try to improve the system and have a better system. So I'm not a fan of this idea that private funding is somehow good or beneficial, but it's a reality that and given that in India there is a cut and reduction in public funding in many meaningful ways, that people will have to look for whatever source of funding is available.
Because if you look at China, they are increasing their uh, funding far more than if you look at the US, they are increasing far more than the US. So,
Yeah.
how does this affect the future talk?
So as you say, clearly in China, this is very important that they have these large institutions. I was in China a couple of years ago. I remember walking from Tsinghua University to the Chinese Academy of Sciences, which is maybe a few kilometers, and it was just remarkable. You just look around the street, and there is Institute of X and Institute of Y. These the level of investment that has gone into creating that academic ecosystem just in that small area in Beijing is just enormous. And it's we do need that kind of public investment in education here, and the long term consequences are obviously quite serious, right? If we don't have just look at something like research in artificial intelligence. Now, this is clearly a technology that's very important, but it's a technology that also has, very strong interplay with the research ecosystem. Now, it's a very serious problem for India that, research in this field is dominated by the US and China, and, India is not in the field, the Indian public ecosystem is not in the field. I mean, there are some people who might be doing good work, but as a whole, we don't have the research
Elegance here.
to match this, and that's a very serious problem. I feel it's of great concern. So I feel in the long run it is very problematic if we don't have that investment in research.
So, if AI, like semiconductors and frontier science, increasingly determine geopolitical power, so does the underinvestment in research eventually become a sovereignty issue?
It does become a sovereignty issue. I think, in the case of AI, this might be coming sooner than we think, because in the end, if the Indian government, does not, or India does not have sovereign frontier models that can compete with the best models in the world, which we don't have. Then it becomes a sovereignty issue in many ways. Even in something as simple as cybersecurity. So if you look at the latest model that was released by Anthropic, the so-called Claude Mythos. They didn't release it to publicly because they felt that it would be a cybersecurity risk. But so there's some number of companies that might have access to that. But what does it mean for India? I mean, maybe India can go to Anthropic and say, well, please include us in this. But that's clearly not a viable long-term way to proceed. And I think that there's a broader problem here: the lack of investment in research. It's the unwillingness of the current government to have large scale public investment in higher education. So it's the belief that that was an Nehruvian ideal, and now we don't need to do that, and somehow researchers should engage with industry and get their own money, and we should have. So it's this very capitalist outlook towards how knowledge is generated, and I think that's clearly not serving the country well.
So, using artificial intelligence in your work of theoretical physics in any way?
Yeah, so I mean, I have been interested quite a lot recently in both science for AI, which is the question of trying to understand how and why these models work from a scientific perspective, and also in the issue of AI for science, which is trying to see if these models can be helpful in advancing science. In fact, in theoretical physics, in the kind of work that I do, which is theoretical physics related to quantum gravity, black holes, what's called high energy theory. There, these models have so far not been extremely successful. They've not had any huge impact of the kind that they might have had in other fields, like say protein folding. And the reason for that is that we are not a field that's a very data rich field where there's a lot of data crunching that's required to produce new outputs. The field of fundamental theoretical physics is generally a field where one is looking for simplicity or new patterns, looking for the basic laws that describe the world. And that is not something the models are currently superhuman at. That being said, however, if one looks at state of the art large language models, they're increasingly becoming good at theoretical physics, and they've also become, so they are not yet at a superhuman level, but they're still already very useful while writing a paper. If one wanted to do some calculation, one puts, there many times one comes across something where one says, well, that's in some textbook somewhere, and then one can go look up the textbook and see how that calculation is done there. But often that could just take several days before one pulls out the right reference and one figures out how some calculation is done. And these models can do a lot of these things very fast. So right now they're already very helpful assistants. Whether how much of an impact that will have on the field, only time will tell. It depends also on how the models will evolve.
So, the breakthroughs in theoretical physics usually come more from compression and conceptual reframing than from processing huge amount of information.
Correct. And as you said, breakthroughs in theoretical physics are effectively, are really about, as you said, exactly, conceptual reframing. And they're not just about, processing a large amount of data. And so far, these models are not clearly not superhuman at that. They're superhuman at processing large amounts of data, but they're not yet in a position where they're able to have, supremely interesting or very interesting new conceptual ideas. They can do a lot of standard calculations, as I said, and that's actually also surprising. It's an ability that they've developed in the past year. 1 year ago, they didn't have the ability to do graduate level physics calculations. They now do have that ability, but they still don't have, the ability to have vision, ask the right questions, generate new concepts. We don't know if they'll develop that ability. They might, but they might not also. Some people believe that they will develop the ability. It's also possible that they won't develop the ability, that their development will saturate. It's really something that we will know the answer to only in a few years from now.
So how do a great physicist develop that instinct? Because it doesn't seem teachable in the same way technical skill is.
Yeah, I don't know. I don't know how physicists. Actually, it's something that all physicists do. It doesn't have to be only giant breakthroughs. In some sense, our work, our original work, is always about creating new paradigms, about thinking about things in a different way. Uh, I I don't know how people develop that skill, or even how it is taught. Often in the current system, it's taught by osmosis. In that, you stay around a lot of people who do it, and you see it, and then you start doing it yourself. Uh, so there isn't a procedure we have for teaching people how to work in theoretical physics, except for that, which is that you immerse people in an environment where a lot of good research is happening, and then they learn to do it as well.
So we talked about the selection process for the PhDs. So when they get in, so there is a publishing track. I mean, you made headline recently for refusing referee for the Nature's Communication over their $6,000 fee, which is a great principal stance, I think. But a 26-year-old postdoc who want publish a paper, what should he do?
Yeah, just to be clear, there are two issues here, right? I would never criticize anybody with, not doesn't have to be a 26-year-old postdoc. Even a senior researcher who feels that they need to publish in some journal, because it's important for what they're doing, or it's important. It's not their fault that the system is the way it is. It's a little like the discussion we had earlier about funding. They need to function in the system, and I would not say that they should. They need to boycott these journals. It is true. So that's one point. So that about the individuals, I don't want to criticize individuals who choose to publish in these journals because they feel it's important. That's how they need to function. That being said, there's a systemic issue, which is the fact that you have large academic publishers who are profiting off the work of academics without doing anything meaningful in the process is very problematic. Not everybody understands how academic publishers function. It's the way academic publishers function is that an academic set of academics does some research, they write a paper. They do everything. They typeset the paper. They do everything. They send it to the journal. The journal acts as a post box. So they might take it and send it to a referee. The referee is another academic. That academic does this part of actually peer reviewing the paper. They send it back to this post box. The post box sends it back to the author. And, there might be a few back and forths. And in the end, they either publish or don't publish it. But notice in this process, the value added by the academic publisher is basically close to zero, right? What did the academic, everything was done by academics. The research was done by academics. The writing was done by academics. The refereeing was done by academics. Everything was done by them. But the academic publisher now takes this research and might sell it back to the authors, for a high price. And if somebody can't afford that high price, then you don't get access to that research that your colleagues might have produced based on publicly funded research. So it's a completely absurd model, this model of academic publishing. In fact, in our field, in the field of high energy physics and string theory, we have solved this problem. We don't have these large academic publishers who are able to basically, exploit academic researchers in the manner that they do in other fields. Now, in other fields, the problem is that there are, how do journals like Nature and so on operate in the end? They also operate because not just because they're these academic publishers, but because these academic publishers have the cooperation of a set of scientists. So there might also be some scientists who, maybe are on the editorial board of Nature and so on. And those scientists find that this system gives them a significant amount of power over scientific research because they can decide, what gets published and what doesn't. They can act as gatekeepers. So it's a problematic system in many other fields where, or in some fields where, these journals act as gatekeepers, and the reason they're able to survive is that there's a set of people who, have prestige in science by virtue of these journals, and find that it's a way to keep their power in science. So it's a but I think there are clearly solutions, and the field that, as I said, I work in high energy theory, does offer an alternative model. So it's not so hard to find this model. In fact, even in machine learning and artificial intelligence, as we were discussing, uh, these academic publishers are not present. The way things work is through these large conferences, where people submit papers, and people who submit papers also have to peer review them. But you don't have this intermediary of an academic publisher who doesn't actually contribute to the work but extracts a fee, and puts research behind paywalls. So I think there are clearly many alternate solutions that are available and that people have, and hopefully going forward, academic publishers will be gradually be replaced. But just to say once again, I don't want to criticize any individuals who has to. Many individuals have to engage with them. That's the reality of the world that we live in, and I don't want to criticize any individuals who do engage with these publishers.
So why has the scientific community tolerated that model for so long? So long. So if the researchers themselves already do most of the actual intellectual work.
Yeah, it, it's as you said, right? It's the fact that there is, in the end, there are vested interests on both sides. There are also vested interests within the scientific community who find that this is a convenient way by means of which they can act as gatekeepers, because if you're the editor of a major journal, then you have the ability to act as, it gives you some power and prestige in this field. So the scientific community, there's clearly, if one takes a step back, it looks like an absurd model. But the reason it survives is because there's a lot of inertia in the system. And so the only way, you see, because as you said, let's say you're a scientist who's working in a field where publication in Nature is considered to be important. So let's say you decide that I don't want to publish in Nature. I'll go publish in some other journal, which is an open source journal. The problem is that you pay a personal cost for that. In my field, actually, I don't pay a personal cost for that. But in other fields, people pay a personal cost for that. So of course they don't want to pay a personal cost. So they have to be part of that system, and that's how the system survives, because there's a lot of inertia. So unless there's a collective effort by the whole community to break out of the academic publishers, it can't happen, right? Because as I said, in some fields like in high energy theory, it has happened, but it requires that collective effort. The system has a lot of inertia as it stands.
So let's actually apply that exact idea of institutional inertia to much more physical system. So India's nuclear expansion, we have been highly critical of this, pointing out that importing French or American reactors is an economic disaster. But just the last month in April 2016, the prototype of fast breeder reactor at Kalpakkam finally went critical. It's 100% indigenous and breeds its own fuel. So does a successful homegrown reactor like this change your calculus on nuclear power?
Well, so yeah, as I said, there are two separate issues. One is the issue of the expansion that the Indian government has been looking to create, which is based on imported reactors, and it is not an ideological issue. There's just a very clear problem, first on the economic front, on how expensive the cost of electricity will be, and second, on the liability front, the government of India, in order to please these foreign manufacturers, has put in norms which say that if there's an accident, then the foreign supplier will not be responsible for the accident. And what is more, the private company in India that might operate this reactor will also have to pay only a limited amount of compensation, regardless of how much damage the accident causes. So these are very problematic, legal and economic issues. And it's not an ideological thing. Anyone can look at the laws and look at the economics and come to this conclusion. So that is what I've been very critical of. Now, the fast breeder reactor that you mentioned is a slightly separate thing that comes from a different older stream of what's called the three-stage Indian nuclear program. So this is the so-called second stage of the three-stage program. Now, it's true that this fast breeder reactor, there was a lot of discussion about it some time back. I think it's also important to realize how delayed the second stage of the program is. So if one looks at the history, one can go back and look at what Vikram Sarabhai was writing. And Vikram Sarabhai was writing that, already writing that, look, the program is delayed because it was already delayed by the time Vikram Sarabhai was, chairperson of the Atomic Energy Commission. And Sarabhai writes, and these are just public documents, you can go and see, that we need to set up one such 500, a 500 megawatt reactor each year in the 1980s. In the 1980s. So this is now 45 years after that, 46 years after that, that the first 500 megawatt reactor has come online. So I think that's the first thing to realize, that this is, how delayed the program has been. Even this particular reactor, this prototype fast breeder reactor, the initial completion date was 2010. So, the completion, it's 2026 now. So there was a tremendous delay in the completion of this reactor. Now, countries around the world have tried these fast breeder reactors, and there was a lot of enthusiasm about them in the 50s and so on. But soon it was realized that from an economical point of view, just the standard, once through nuclear cycle provides, which, not breeder reactors, just standard, fission reactors, which are not trying to breed their fuel, which are just based on enriched uranium, or in our case, naturally occurring uranium with heavy water as the reactors we use, that those are cheaper than these fast breeder reactors. So it's not, I don't think this fast breeder reactor is a very significant milestone in terms of the country's energy security, or that, the fact that we have managed to finally bring this fast breeder reactor online will have a significant effect on at all on the energy scenario in the country. So, I think one should be quite clear about that. There's a second issue, which is that the prototype fast breeder reactor, there are studies that suggest that it can be used to produce weapons grade plutonium for bombs. One of the in the when the Indo-US nuclear deal was signed, India put some number of reactors under IAEA safeguards, and one of the sticking points was about whether this prototype fast breeder reactor will be put under safeguards or not, and eventually it was not put under safeguards. So, there's that strategic angle, and that's a separate discussion entirely. But the issue of, uh, from an energy point of view, I frankly don't feel this is a very significant.
So, if there is zero accountability in the Department of Atomic Energy for more than 50 years today, so let's that apply to safety. The Kalpakkam reactor uses liquid sodium as coolant, which is noticeably difficult to handle. It catches fire in the air and explodes in water. So, if an engineer at IGCAR spots a fatal safety flaw in that sodium piping tomorrow, do the institutional dynamics and the lack of accountability you have described make it basically impossible for them to blow the whistle without destroying their career?
Yeah, I don't know. I can't say about this specific point, but you're right that there's a concern about safety. The other concern, as you said, one concern has to do with the with liquid sodium that is used. The other concern has to do with the structural aspect of the reactor. It's called a positive void coefficient of reactivity. It's a structural deficiency that the Chernobyl reactor also had, which is that, if there's a void created in the coolant, then this void can increase the rate of the reaction, which can therefore lead to more heat being produced and a larger void being produced. So it can lead to a runaway reaction. So this reactor, at least the initial design documents of the Department of Atomic Energy itself noted that the reactor, this reactor, the PFBR, has a positive void coefficient of reactivity. So, I mean, this is just something they said publicly. So that is a concern. Now, that discussion seems to have, did happen again 15 years ago, but now does not seem to be discussed again. So, you're right. This issue of safety is important. It's also important in other ways. The Atomic Energy Regulatory Board in India, for instance, doesn't have sufficient autonomy. So, who is who is it who is really in charge of safety? And does the regulator have suitable autonomy? So those are all serious concerns, as you say.
So, so this brings me to my final question, not just final, but in your day job doing theoretical physics, your standard truth is absolute. So if a mathematical equation has a fatal flaw, the theory dies. But in your activism, you are dealing with the world where state bureaucrats can just erase the uncomfortable variables from the discussion. So you have been also talked about the Sutra code models. So why do rigorous mathematical models often fail or get distorted when applied to complex social and political issues, realities?
Okay, so this Sutra model is an interesting thing. This is now a discussion from a long time back from the COVID pandemic. Um, and the discussion as follows. At the time of the COVID pandemic, many mathematicians and physicists jumped in and tried to model this pandemic. And there are some very simple differential equations that are used to model the pandemic that are used, that are given in some textbooks on modeling the spread of infectious diseases. And many people went and read those textbooks and then started to make real world predictions about what would happen with the COVID-19 pandemic. And that was, of course, a very serious problem because, those equations were very simplified. The data that we had was noisy. So it was, but, physicists found that they could write something and it would be reported in the newspapers and they would be interviewed and so on, prominently. And I think it was very problematic that some scientists kind of gave in to that and went ahead and started making predictions which they shouldn't have done. Now the Sutra model is a specific model. It actually comes from a slightly different dynamic. So the government of India put in place this so-called supermodel committee, and I'm speaking from memory, so I might be. I hope I have the details correct. They put in place this thing called this. They wanted to have a supermodel which would somehow you know be this very good model that would predict the trajectory of the pandemic. And now the supermodel committee had various members. One can go look them up publicly. But the model that they came up with was a Sutra model. The Sutra, if I remember, was susceptible, uh, un susceptible, undiagnosed, uh, tested and recovered approach. Yeah. So this stands for saying that you will divide the population into four different buckets. So people who are susceptible means those who can get the infection. Those who are maybe undiagnosed, if I remember correctly, those who have been tested and know that they are positive or not, and those who have recovered or those who have been removed. So this is the kind of some approach that, as I said, comes from very basic textbooks. And these very basic textbooks usually use what's called the SIR model, which is susceptible, people who are susceptible, people who are infectious, and people who have recovered. So this supermodel committee, this committee that was made with great fanfare, went and said, instead of the SIR model, we'll use the Sutra model. We'll just add one more equation to this mix of equations. This is a completely trivial modification. Any undergraduate, if you gave it to them, you gave them this SIR thing and said as a homework, can you modify it slightly, would come up with some modification like this. So it's very unfortunate that this committee that was formed by the government of India with so much fanfare came up with this completely trivial model. But fine, they came up with this completely trivial model, but then they proceeded on the basis of that model to make predictions. And the good thing about the archive is, sorry, can you hear me or is it disconnected? So the good thing about the archive, which is where this committee posted their papers, is that the archive has a long memory, so you can go back and look at the paper that they posted on this issue. So one of the things that they said in their paper is that fine, they had this completely trivial model, which of course one shouldn't take seriously for anything, right? The model was a complete failure in terms of predicting anything about the pandemic. But the thing they wrote in the paper was, some countries imposed a very strict lockdown, and therefore there was a second wave. Some countries didn't do much, and therefore the pandemic spread and a lot of people died. Then they write that India is perhaps the only major economy to have got the the strategy correct. And it can be rather easily shown, I don't remember the exact words, that the actions taken by the Indian government have prevented the appearance of multiple peaks and a second wave. So to see this line in the paper, one has to go to the archive and look at version 2 of the paper, which was in January, 2021, before a few months before the second wave. So not only did the scientists come up with a model that was basically a trivial model, they proceeded on the basis of that model to write in a scientific paper that the government of India's policy was great and optimal, and that as a result of the government of India's policy, there would be no second wave in the country. And one of the authors of this paper, it's very easy to discover who, actually, when the second wave started happening, repeatedly went on social media and claimed, no, no, this is not a second wave. This is just a bump. It's a rise. It's something. And they were repeatedly, of course, they were proven wrong because in the end, the second wave happened. But the serious thing is that as a result of this kind of wrong advice, saying that, saying publicly that there will be no second wave, the government of India lifted a lot of restrictions, right? That is when the Kumbh Mela happened and the Kumbh Mela was allowed to go ahead. And so this kind of poor advice given by opportunistic scientists based on very poor science to the government, which of course is what the government wanted to hear. Which government doesn't want to hear that on the basis of science and maths, it can be shown that their policy is optimal. But it led to very serious consequences. Now, I'm not saying that the scientists were the only ones who were responsible. Obviously, in the end, the responsibility for the second wave and whatever bad decisions were made lies with the government. But the scientists played a very unfortunate role here in terms of first very poor science and b modifying their conclusions, or at least seemingly molding their conclusions to what the government wanted to hear, and that is extremely unfortunate, I feel, and a rather a significant concern from a point of view of scientific ethics.
So I want to go a little bit philosophical here. So why people often more impressed by quantified prediction?
Well, I mean, quantifiability is an important thing. I wouldn't say that quantifiability is not important. And of course, physics is a very remarkable science. So it's a science where we've managed to make very remarkable quantifiable predictions. So of course, it would be great if, we could make those predictions in many other branches of society. But I think what people don't realize is that the way physicists are so successful is that they always look at the so-called spherical cows. There's a joke about physicists that physicists like to think about spherical cows, but it's not an untrue joke. It's actually true that physicists like to look at very simple systems. The systems we like to look at are highly simplified, and they're simplified because then we can do some very sophisticated analysis of these systems and make some predictions about them. Now, if one takes a complex system like, I don't know, society, then, we can't do the same things. And so while one might want to replicate the success of physics in these other systems, sometimes we are just not there yet. And it's worth recognizing that limitation. And as you said, in the pandemic, this was not done by many people, which should have been done.
So actually, I want to discuss some global issues with you. Recently, International Olympiad happened in India, in Mumbai. TIFR hosted that. But due to Gaza issue, the Israel was banned.
So first of all, just to say, yeah, the International Olympiad in Astronomy and Astrophysics happened in Mumbai. The International Olympiad is a set of, high school competitions, actually. These are not research scientists, but they're competitions held for high school students in which countries send their teams. So they're like the Olympic Games, but at a high school level and for science. Right? So in the Olympic Games, as you know, for instance, Russia is not allowed to send a national team because of its actions in Ukraine. So the athletes from Russia might be able to participate as individuals, but they can't send a team under the Russian flag. And that's, by the way, also happened in many of these science Olympiads, that students from Russia can participate as individuals. So Russia often used to be on the top of these Olympiads, but if you look at the past few years, it's not there. It's not there because students can participate as individuals, but the country team can't participate. This is, the fact that you don't allow a country team to participate is a logical thing because the country's government sponsors the team. So I was also part of the Indian team for the physics Olympiad. And, we were sent by the government. We were representing the country. And, if when one wins medals and so on, after that, the country also, uses that for propaganda. Now, as for the last 2 years, Israel had been carrying out a genocide in Gaza. It's perhaps the first live stream genocide in history. And this is not something I am saying. If you look at the UN Independent Inquiry Commission, they found that Israel had committed a genocide. The International Association of Genocide Scholars found that Israel had committed a genocide. So there is no doubt from many independent sources that Israel was committing a genocide, absolutely brutal genocide in Palestine, in Gaza. Now, in such a situation, it's very important that, the government should be held to account, and anything that the government of a country that's committing a genocide can do, can use for propaganda or positive publicity, one should try to stop. And it's the responsibility of all of us, to do whatever we can to hold this kind of a government to account. So when the Olympiad happened, many Indian scientists wrote to the Olympiad. So the Olympiad is governed by what's called an international board. We are not part of the board. We were just external scientists. And we wrote a letter to the board of the Olympiad saying that, look, here are the actions that the Israeli government is taking, and they're, these are horrific actions, what they're doing. And, therefore, you should not allow Israel to participate as a national team. So if Israel wants to send students individually, that's fine. Now, as it happens, Israel had not sent a team this year anyway, perhaps because of security concerns. So we don't know what the reason is, but they would have sent a team the next year. So the international board considered this letter. The international board is an autonomous organization. None of the scientists, there were 500 scientists who signed the letter, were part of the board. But the international board considered this, which had representatives from 60 different countries, and they decided by an overwhelming majority that Israel should be suspended. So I feel this was a very positive step. It was a very good thing that Indian scientists took this stand, because it's in, I don't think there are two views about the fact that, what the Israeli government was doing was absolutely criminal and horrific. And the fact that we took this stand to hold, to say that the Olympiad should hold Israel to account was a very positive thing. And I'm very proud of all my colleagues who supported that effort. In the end, the decision was, of course, made by the Olympiad. It was not made by us. It was and I'm very glad that the Olympiad openly discussed this. For instance, there was a similar effort in the Maths Olympiad that failed because the president, or the, I don't know, but it is said that the executive committee of the Maths Olympiad didn't allow an open democratic discussion to happen. I'm not privy to the details, but that's what I understand. And I'm very glad that the executive committee of the International Olympiad in Astronomy and Astrophysics allowed a democratic discussion to happen, which led to the Olympiad making the correct decision. So I'm very glad that that happened in India, particularly because the Indian government has not taken a good position. So it was a good sign to show that the people of India still stand in favor of basic human rights and against genocide.
So you work in quantum gravity, where the goal is to understand reality. At the same time, you spend a lot of time thinking about institutions, politics, and public life. Do these two words change how you think about truth differently?
Well, as I was saying, the kinds of questions that physicists think about in their professional life are very simple questions. And we have some notion of, what it means to understand something. And that level of understanding that one gets at in physics is not something that one can get about society, or one can hope to get about society. That being said, clearly the basic idea that comes from physics, which is one should look for truth, one should, be honest, one should not believe claims that are made without evidence, are clearly basic principles that apply also when one thinks about society. So those basic scientific principles, I think, are also important to apply in society. But beyond that, to some extent, these are two different things about two different aspects of what I do. And there are some basic principles, as I said, that are shared across them, but otherwise they are separate.
So to wrap up our conversation, what advice you would give to young students who are just coming to the college, wants to do some physics?
Yeah, I think it's very important, that they should be really interested in the subject. I would say it's really important that they should pursue their work with integrity, with curiosity, and with a lot of interest. Also, maybe something that's different about students who are entering college today is that the world is changing very fast. The world has always been changing, but even from the point of view of people who do science, related to what we said earlier about the impact that artificial intelligence is having, uh, the kind of changes that students today might see in education and research over the next 5 or 10 years might be quite different from the kinds of changes that we saw. So I think about this also with my kids who in some years, not immediately, but in some time, will enter higher education. And, I, so it's a, it's maybe it's an exciting time if with these things, with so many changes and so many potentialities. I can believe it's also an uncertain time. But it's important that people should so it's a challenge to navigate that. Yeah, I don't have any advice, any overarching advice to give, except just that people should try and do what they enjoy and try and do it with integrity, and should be aware of all the changes that are happening around them.
Talking about artificial intelligence, but the syllabus of our colleges is still being same, which is used to be 10 years ago or 20 years ago. So how we should learn? Like it's coming very fast and lots of new things coming, but our learning capacity is not very fast. It's very slow.
Yeah, this is a problem that, of course, is a very significant problem. I don't think anyone knows the answer to this. Right? How should we modify our education system? Also, it's the technology itself is changing so fast. So even in a place like ICTS, I don't think there's any point in for us to give assignments to students, because that's just a question of who uses AI well. So all assignments can be done by AI now.
Mm.
So, so now what are the skills that are valuable, right? There are many problems that we thought problem solving of some kind was valuable, but if models can do it well, then what are the skills that are valuable? So these are really very important questions, but I don't think I have the answer. I mean, it'll also take a much longer discussion for us to go through it, but I don't think I have the answer to those questions. I don't think anybody really does. I mean, we are all kind of struggling through this new period. And it's clear that the education system will have to change, and we should think about how to prepare students for, and how for us to prepare for what is coming. But I don't think there are any very easy answers. You're right, of course, things haven't changed, but it's not like in other places things have changed, or that it's very easy to immediately adapt to what is happening. So it's a quite a complicated problem and issue. I still want, for instance, that my children, we still try and teach them. They should understand basic science and mathematics. Now, when I was studying these same problems, even, there was no AI I could look up. I would sometimes struggle with a problem. For a long time, I wouldn't know what the answer is. There was no one I could even necessarily even get the answer from immediately. I remember thinking about problems in physics in class 11th and 12th for long times and not knowing the answer. Now that's not the case. Now you put the answer, you put the question, you get an answer. So I don't know how students should learn. Clearly, there are some skills that are still valuable. It's still important. They should be able to understand basic things. They should have basic analytic skills. They should also know how to operate these models. They should be familiar with them as well. But I actually just don't know what the answer to that is. It's a question we are all trying to figure out.
I think we have a great discussion. We have covered lots of topic. Maybe we missed some physics, but next time we will discuss that too.
Sure.
So thank you for joining us today.
Okay.
It was
Thank you
really
very much.
great
Thank
discussion.
you. Thank you.
Thank you so much.